What's up, everyone? We're back for our final day of Unit 8 with the unit circle, and we have talked about sine, cosine, and tangent, but surprise, there's three more trig functions that we need to know. And those are reciprocal trig functions, and that's what we're going to talk about today. So here's a problem from day one of this unit where we're given a point, and just to kind of talk about what a reciprocal function is. Without going into this a whole lot, if that's our theta and we're trying to write our trig ratio for sine, opposite of that angle is 12, hypotenuse is 13, cosine is this, and tangent is this. We've already done that. So a reciprocal function, those are the cosecant, secants, and cotangents. And you won't find those on your calculator, but there is a way that we can write them as the reciprocal functions and whatnot. You won't have a calculator anyway, but reciprocal simply means just a flip. So, you have to understand which ones go together, which functions are reciprocals of one another. And what I like to think about it as is it's opposite of what you think. Like there's cosecant and secant, right? And cosecant is actually the reciprocal to sine since cosecant starts with COS, you might think it goes with cosine. And secant starts with an S and sine starts with an S. And you might think those go together, but those, in fact, do not. Tangent and cotangent go together, though. So reciprocal just means to flip. So if we know what sine is, then we can determine what cosecant is just by flipping. Instead of opposite over hypotenuse, it's hypotenuse over opposite. Same thing with secant and cosine. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. And cotangent was opposite over adjacent. Tangent is opposite over adjacent. Cotangent would be adjacent over opposite. So if I asked you this question and I asked you for all six exact values of all six trig functions, not just sine, cosine, and tangent, but cosecant, secant, and cotangent, then we would just take, we would flip whatever it was, just like I said. So 13 over 12, if cosine of theta is 5 over 13, then the secant is 13 over 5. If tangent is 12 over 15, then cotangent is 5 over 12. So let's look at this example that we also did. And here, when I did this in class, I rationalized the denominator and I simplified the fraction. For this example, for the sake of time and whatnot, I'm not going to do it. And I'm actually not going to require you to do it either. I don't think you'll have something that's necessarily like this, where you have a square root that's in the denominator that can be simplified. And if you do, it will already be written for you that way, from what I remember. So to go ahead and write our trig ratios for our sine, cosine, and tangent. Opposite over hypotenuse is 4 over square roots of 20. Adjacent is 2 over square roots of 20. And tangent is 4 over 2, which is 2. Now, in quadrant 2, we do need to remember that sine is the only thing positive. All students take calculus. So all students take calculus. So cosine and tangent, notice how they're both negative in that quadrant. Now, to write the cosecant, that is the reciprocal of the sine. So if I just flip the numerator and denominators, I get square roots of 20 over 4. Flip the numerator and denominators for secant for the cosine, and flip the numerator and denominators for cotangent. Now, notice the 1/2 is coming from some of these. You're going to have to think, well, if that's not a fraction already, negative 2 over 1 is the same thing as negative 2. So if I put that 1 in the denominator and I flipped it, the 1 would be in the numerator now. Okay, so I would encourage you to fill this out just as some additional practice real quick in your notes. And then find all 6 trig functions of theta of 60 degrees. So we know if we fill this out, we should be able to see the y value at 60 is square roots of 3 over 2. The x value is 1/2. And then if we do y divided by x, we get square roots of 3 for tangent. So going back and looking at our reciprocal, sine and cosecant go together. Remember, those don't seem like they would. But we do have to remember that sine and cosecant go together. So if square roots of 3 over 2 is my sine value at 60 degrees, then 2 square roots of 3 is my cosecant value. I'm not going to have you rationalize the denominator here, although you should be able to. You would get 2 square roots of 3 over 3. If cosine of 60 degrees is 1/2, then the secant of 60 degrees is 2 over 1, which is just 2. And square roots of 3 over 1 for tangent of 60. So 1 over square roots of 3, which would just be square roots of 3 over 3 if we were to rationalize that. So here's some examples using those reciprocal trig functions. So cosecant of 180 degrees, we need to first recognize, okay, what are we talking about here? We're talking about, when you have a reciprocal trig function, first think about what its reciprocal trig function is. So cosecant is sine. So I'm going to first think about what is the sine of 180 degrees. Well, sine is the y value. So if I go over to 180 degrees, x is -1, y is 0. So if I have 0 is my sine of 180 degrees, so that's the same as 0 over 1. If I flip that, 1 over 0 is the cosecant, and anything divided by 0 is undefined. The secant of pi over 3, that is our 60-degree one. That's our third line up from the x-axis. So if I count up, we're looking for cosine. Cosine is the x, so we start counting 1, 2, 3, right, on the x value. Well, 1's the first thing we have, so that's our 1/2. So cosine of pi over 3 is 1/2. The reciprocal of that is 2. Cotangent of 135 degrees, that is in quadrant 2. How far away from the x-axis is that? Let's think about it. That's 45 degrees. So that is our square roots of 2 over 2 for both x and y. So our 45-degree angle, taking it back to that, square roots of 2 over 2. Also in quadrant 2, remember all students. So students is sine. Sine is the only one positive in quadrant 2. So this is going to be negative. And so if I do y divided by x, so root 2 over 2 divided by root 2 over 2, that's just 1. And in this case, since I'm in quadrant 2, that's going to be -1. That would be the tangent. -1 over 1, if I do the reciprocal of that, I get the same thing. It's -1. So the tangent of 130. So first, find the actual function, sine, cosine, or tangent, and then just flip it. That's how we're going to approach these. If I flip -1 over 1, I still get -1 over 1, which is -1. All right, let's look at cotangent of 2 pi. So I'm going to look at tangent of 2 pi. So if I go all the way around, let's see. So x is 1 and y is 0, right on the positive x-axis. So y divided by x would be 0 divided by 1, which is 0. If I flip that and do 1 divided by 0, we can't divide by 0, so that's undefined. Secant of 300 degrees, that is in quadrant 4, and that is the reciprocal trig function for that is cosine. So let's think about what is the cosine of 300 degrees. All students take calculus, so I'm going to be positive in quadrant 4 because cosine is positive, and that is the reciprocal to secant. So cosine of 300 degrees, how far away am I from 360? That would be 60 degrees. So if I have my quadrant 1 filled out, starting at the top, 1, remember cosine's my x value, so I start 1, 2, 3 going top to bottom, and then 1, 2, 3 going bottom to top. But the 60 degree, that's the first thing I write, so that's 1. And so that's my 1/2 spot. So the the cosine of 60 degrees is 1/2, and therefore the secant of 60 degrees would be 2 over 1, or just 2. And since I'm in quadrant 4, cosine is positive, so therefore secant is positive, so it's just 2. Cosecant of 4 pi over 3, the reciprocal for that is sine. So I want to think about the sine of 4 pi over 3. What quadrant am I in? I am more than 1, so that's all students take. So that's 1 more than 1. I am in quadrant 3, where sine and cosine are both negative. So cosecant and sine go together. So since sine's negative in quadrant 3, cosecant is also negative in quadrant 3. My reference angle is pi over 3, so that's the very first, that's the third bar from the x-axis in the first quadrant. So counting from the top to the bottom on the x's, 1, 2, 3, but sine is y, so I'm counting from the bottom to the top, 1, 2, 3, and that's my root 3 over 2. And because I'm in quadrant 3, that's negative, and now I have to flip it though because it's cosecant. So it's not root 3 over 2, it's 2 over root 3, and it's negative. Okay. So now we're going to look at some more sine type of stuff. So determining what quadrant theta is in. If I give you something like this, we need to understand what this greater than or less than thing means. If you have something less than 0, that just means it's negative. If it's greater than 0, it's positive. That's all we need to be focused on. So I'm going to go ahead and label this. If sine of theta is less than 0, that means that it's negative. And if tangent of theta is greater than 0, that means that that's positive. So up here above this, I'm going to make a little note to myself, and I'm going to write what quadrants is sine negative in, and I'm going to write what quadrants tangent is positive in. And there's only going to be one quadrant that both of these things are true. So sine is negative with all students take calculus. Sine is negative in quadrants 3 and 4. Okay, so now where is tangent positive? Well, everything's positive in quadrant 1, and also tangent is positive in quadrant 3. So these two things are true. Now, what do they both have in common? Well, they're both, these things are both true in quadrant 3. So what quadrant is theta in? It's in quadrant 3. Another way we can do this is by, if you want to take the time, you can shade this too, if you don't want to write this out. So if I want to think about, okay, where is sine negative? It's negative in quadrants 3 and 4. So if I shade that, and then I shade where tangent is positive, and I see where they overlap, that's in quadrant 3, like that. All right, here, cosine of theta is less than 0, meaning negative, and cosecant of theta is greater than 0. So I can think about that as sine, right? Sine and cosecant are reciprocals. So I can just ignore that if I want to and just say sine is greater than 0. So where is cosine negative? All students take calculus. Cosine is negative in quadrants 2 and 3. And sine is positive in quadrants 1 and 2. So where are both of these things true at? We'll look to see what happens in both of them. We have a quadrant 2 under cosine and quadrant 2 under cosecant. So that must be what we're looking for. This is in quadrant 2. If I shaded that region, I'm just going to shade quadrant 2 and 3 for the cosine less than 0. And then where cosecant is greater than 0, think about where sine is positive. That's in quadrant 1 and 2. They overlap in quadrant 2. All right, let's find the value of all 6 trig functions given the angle with the following information. Tangent of theta equals 4/3. The terminal side of theta is in quadrant 3. So we're given what quadrant we're in. And so this is not a unit circle problem, by the way, but we're going to write all trig values. This is not a unit circle problem. This is just giving you the tangent of the angle is 4/3. The terminal side is in quadrant 3. So I'm going to label what I know, and remember that when we label these, tangent is opposite over adjacent. So I know if I label my sides, and that's tangent of that, I know that the opposite of the angle is from the numerator, and then the adjacent is in the denominator. So to determine what my hypotenuse is, I need to do Pythagorean theorem, and I get 5. Okay, so now I'm going to finish writing the rest of these. I can go ahead and write cotangent if I want. Cotangent's just flipping the tangent, so instead of 4/3, it'll be 3/4. So, and I'm just using y over h and x over h just as like the x value over the hypotenuse kind of thing. We do need to make sure if in quadrant 3 that cosine and sine are both negative, because that's tangent's the only thing that's positive. So we do have to remember that. So the sine of theta in quadrant 3 is opposite of the angle is 4, hypotenuse is 5. That's where that's coming from, and it's negative in quadrant 3 because that's y, the y value. Also, cosine is adjacent, so x over the hypotenuse, 3/5, and in quadrant 3 we're also negative. Now the reciprocal values, just flip them. So cotangent is 3/4, cosecant is negative 5/4, and secant is negative 5/3. All right, let's find the 6 trig functions given theta in the following information. We're given secant of theta, so in other words, the reciprocal of cosine is 6/5, and sine of theta is less than 0. So we need to think about this like this. We've already seen where sine of theta is less than 0. That just means that that's negative. But also, we're given secant of theta is 6 over 5. We're given that that's a positive number. So we can think about this as cosine being positive. So where is cosine positive and where is sine negative? And that's going to tell us what quadrant we need to be in first. So that's negative in quadrant 3 and 4. And then cosine is positive. It doesn't say positive, but 6 over 5, it doesn't have a negative sign there. So 6 over 5 is a positive number. So cosine is positive in quadrants 1 and 4. So this is telling us where we need to draw our reference triangle. So they both share quadrant 4. So this is where I need to sketch my reference triangle at. And then I'm going to label what I can. So remember, secant is the reciprocal to cosine, and cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent. So that 6 is my hypotenuse. And the sine 5 is my adjacent to that angle. Now I can use Pythagorean theorem to determine the other side, which is the square root of 11. I'm just going to leave that as the square root of 11. And now I'm going to fill out the rest of my trig functions. So I have what secant and cosine. I need tangent and sine. Remember, in quadrant 4, tangent and sine will both be negative. So both of these next 4 should all be negative. So sine is opposite of the angle over the hypotenuse. So square root of 11, make sure that negative is on the outside of the square root. If it was on the inside, it would be an imaginary number. So the cosecant is the reciprocal of that, 6 over square roots of negative square roots of 11. I don't care where I put that negative sign, by the way. I can put that out in front of the fraction. It just makes it easier knowing that that's the y or whatever. Tangent is opposite of the angle over the adjacent side. So negative square roots of 11 over 5, and then 5 over square roots of negative 11. And then finally, y'all's last thing to complete for this is worksheet 8.4. There's actually 2 practices that go along with this one lesson, 8.3 and 8.4. Both of those need to get complete. Good luck. Make sure you ask questions as you have them.